In this video, we're going to talk about complex numbers and properties. So, simplifying expressions with I. Unfortunately, Desmos does not know how to deal with imaginary numbers because Desmos is only graphing on the real number plane. So we're going to treat I like it's a variable and simplify like you would any variable expression. Then you're going to use the powers of I below to simplify I. To simplify the powers of I, you take the exponent and divide it by 4. Then we're going to look at the decimal part of that answer. If the decimal is a 0.25, we know it simplifies to I. 0.5, the exponent simplifies to -1, 0.75 to -I, and if there's no decimal, it's just 1. The other thing we need to remember about imaginaries is that they occur in conjugates, meaning there's A plus BI and A minus BI. So let's do some examples. Which one is an equivalent form of the following expression? So first, we're going to ignore the 2 and we're going to simplify the square root of -9. We know the square root of +9 is 3, and then the square root of -1 is I. Multiply that result with the 2 that's out front, and we get 6I, which is option D. Which of these is equivalent to 1? So this is going back to those exponent rules that we talked about right here. So if we want to get a result of 1, we want there to be no decimal. So we divide each of these exponents by 4. This one will give us 6. Here we get 10.5, 16.5, and 20.5. So the only one without a decimal was the 6, which means I to the 24th would simplify to 1. We need to simplify this. So one of the rules of denominators is that we can't have an I in our denominator. To eliminate it, we want to multiply by the conjugate. So 1 plus 4I on top and on bottom. In both cases, we're going to have to double distribute. And now we simplify. 2 plus 11I. I squared we said would simplify to -1 because 2 divided by 4 is 0.5. On the denominator of 1, the 4I and minus 4I would cancel out, so -16 times -1. So we'd have 2 plus 11I minus 12 and 1 plus 16, which finally simplifies to -10 plus 11I over 17.
So we have many properties we need to know, and we need to know them by name. The addition, subtraction, multiplication, and division properties of equality, we use these all the time when we're solving an equation. They say that we can add, subtract, multiply, or divide the same value from each side of an equation. The next set of properties we have some for addition, and we have some for multiplication. Let's start with the commutative property. I almost see the word commute right here at the beginning. And when I think of commute, I think of going from home to work, and then at the end of the day going from work to home. And that's exactly what's happening. From home to work, from work to home, it's different order, but it's the same thing. So we change the order. but we remain the same. A plus B is the same thing as B plus A. Same thing for multiplication. A times B is the same thing as B times A. Notice that the order changes. Our next property, the associative property. I see the word associate in there. You associate with different groups throughout the week. Notice that the order does not change. A, B, C, A, B, C. A, B, C, A, B, C. The order is not changing. What's changing are your grouping symbols. So we change the group. We add A plus B together first and then add C. And that's the same thing as adding B and C together first and then adding A. Similar idea with multiplication. We're changing the group, not the order. Next is the identity property. If you keep your own identity, you're not changing. If we're talking addition, we can add 0 to a number and it does not change. A remains the same. Or we can multiply by 1 and A does not change. It remains the same. It keeps its own identity. The identity stays the same. Zero is called the additive identity, and 1 is called the multiplicative identity. They're the numbers that we can either add or multiply to something and not change the value. As opposed to the inverse property, inverse undoes stuff. If we add two opposites, A and negative A, they cancel each other out and we get that additive identity 0. If we multiply two reciprocals, A and 1 divided by A, they cancel each other out by multiplication and we get that multiplicative identity. So inverse property, they undo things. I'll just say undoes stuff. Depends on if we're adding opposites or if we're multiplying reciprocals. The closure property, you don't see the closure property that often, but what that means is the real numbers, the set of real numbers is a closed set. Based on addition, if we add any two real numbers together, we'll get another real number. So it's a closed set. Same thing, it's closed under multiplication as well. If we multiply two numbers together, two real numbers, we will get another real number because the real number set is a closed number set. Okay, let's look at some more properties. Some of these might be familiar. Distributive property, that's probably one of the most used properties we use in algebra, right? Distributive property says if we've got a number multiplied to a set of parentheses, then we multiply it to each part of the parentheses. So that's just distributing the value of A. We multiply it to B and we multiply it to C. You might see the distributive property going backwards this way. That's fine. The trichotomy property, tri means 3, so there's 3 things going on here. If you're comparing two numbers, either they're going to be equal to themselves or to each other, one of them is less than the other, or one of them is greater than the other. Seems pretty simple, but that property has a name, and it's called the trichotomy property. Substitution property. Probably one of the most used properties as well. It says you may replace a quantity with an equivalent quantity. That's pretty, we use that all the time. Let's say we have 2x equal to 10. The substitution property. This is a property that we use almost all the time as well. And it says that we may replace a quantity with an equivalent quantity. For example, if we're solving this equation, let's say we have x equals 2 times 10. Well, of course, 2 times 10 is 20, so what I can do is I can replace 2 times 10 with an equivalent expression, which is 20. And that's the substitution property. It's not the multiplicative property, because the multiplicative property says I need to do multiplication to both sides of the equation. This is simple substitution. I'm replacing 2 times 10 with a 20, an equivalent number. And finally, we have our reflexive, symmetric, and transitive properties. Notice the order, R, S, T. They're in alphabetical order. And we start with the simple thing. we go to a more involved thing, and then we go to the most involved thing in order. The reflexive property, you probably reviewed this much in geometry, that anything is equal to itself. And that's a pretty silly property, but it's got to have a name, so it's called the reflexive property. It's like you're looking in a mirror. The symmetric property says that if we have A equals B, then B equals A. Do not get this confused with commutative property. Commutative property is changing the order of the addition or changing the order of the multiplication. The symmetric property is changing around an equal sign. For example, if you came down to an equation and you said that 5 equals to x, we can flip that around and feel a little bit more comfortable with x equals 5. That's an example of the symmetric property. And finally, the transitive property, you looked at this in geometry as well, very similar to the law of syllogism. If A equals B and B equals C, then A equals C. We have that connection right here in the middle so that we can get the beginning and the end together. So let's look at our one example for the properties, example 4. The steps used to solve an equation are shown. So we have 5 steps to solve this equation. The question, what property justifies the work between step 4 and step 5? So we're talking about between step 4 and step 5 right here. What's happening? What's changing? All right. So I'm seeing 1 times r equals 21i, and then it becomes r equals 21i. Well, nothing changed on this side. The only thing that changed is this 1 goes away. What happens when we multiply something by 1 and it doesn't change? That's our identity property, and that's choice A, the identity property of multiplication. And that is our answer. I'd like to go through each of these steps and identify some of the properties that are being used. Let's see between step 1 and step 2, what's happening? Well, it looks like both sides are being multiplied by 3 halves. I'm taking 3 halves and multiplying it to both sides, so that is the multiplicative property of equality. We multiplied both sides by the same thing, that's why it's multiplicative, and it's both sides of an equation, that's why it's of equality. If we had added, it would have been the additive property. If we had subtracted, it would have been the subtractive property, and so on. Now, between step 2 and step 3, let's see what's happening here. 3 halves times 2/3 becomes 3 halves times 2/3, and 14i times 3 halves, okay. Let's look at example 4, our one property problem. The steps used to solve an equation are shown. So we've got 5 steps to solving this equation. And the question says, what property justifies the work between step 4 and step 5? So that's the step 4 to step 5. That's right here. So we need to see what's changing and what property would justify that. So step 4 says 1 times r equals 21i. Step 5 says r equals 21i. Well, nothing changed on this side. The only thing that changed is 1 times r was r. And if we multiply by 1 and nothing changes, that must be the identity property of multiplication. Excellent. So that's exactly what we used, the identity property of multiplication. Let's see what happens from step 3 to step 4. I see that 3 halves times 2/3 equals 1. Well, that is our inverse property. They undid each other. We multiplied by the reciprocal. And I see that 14i times 3 halves became 21i. That is substitution. We replaced 14i times 3 halves with an equivalent expression, 21i. Let's see what happened up here in step 2. It looks like we multiplied 3 halves to both sides. So what's happening in this step is the multiplicative property of equality. Because we're multiplying the same thing to both sides, it's the multiplicative property, and because we're doing it in an equation, it's of equality. If we had added something to both sides, it would have been the additive property. If we had subtracted, it would have been the subtractive property, and so on and so forth. Okay, thanks for watching this tutorial, and let's go ahead and do well with our packet.